Next up, we have oral presentation 21, Springfield, New Jersey, Mission 12 Flight Experiment.
Good morning. We attend the Florence M. Gaudinier Middle School in Springfield, New Jersey. To give you some background information, Springfield is about 20 miles southwest of New York City with about 16,000 residents. This is the third experiment from our school to be sent to the International Space Station. Our experimental question is, will tardigrade eggs hatch and develop in microgravity?
We are students at the Florence M. Gaudinier Middle School, which has about 500 students in grades 6 through 8. The co-principal investigators are Cecilia Perez, Emma Polita, Kripa Patel, and I am Paige Lieberman.
Tardigrades are microscopic animals that can survive almost anything. They were even proven to survive in microgravity, but their eggs haven't. So our question is, are tardigrade eggs able to hatch and develop in microgravity? Based on our research, tardigrades can survive in any temperature, and they can survive up to 30 days without food or water. The results of this experiment will add to the body of information about tardigrades. We came up with this idea when Cecilia was researching animals that are known to survive in space online, and she stumbled upon water bears. We contacted a German tardigrade expert, but he didn't reply, so then we found Dr. Perry. She has helped us with how to collect the eggs, a way to position the light, and information about tardigrades. When we couldn't locate the eggs because our light source was not at the proper angle, we asked if she could supply the eggs. Her and her students collected 40 for us to use in our experiment.
The research we have discovered is that the eggs can go without water for nearly decades. The adult tardigrade is less than 1 millimeter in size. They can survive the most hottest and coldest weather. They can withstand high levels of radiation and withstand being frozen. The tardigrade has a clear to pinkish cuticle and up to 1 millimeter long. The adult tardigrades are mainly found in the water film surrounding algae, mosses, and lichens. So as you can see, tardigrades are remarkable animals.
Our hypothesis states that tardigrades are surprisingly resilient animals. If the eggs are given water and food, then they should be able to hatch and develop in microgravity. The egg is the beginning of the tardigrade life cycle. The tardigrades typically live in a watery environment. The eggs are about under 0.1 millimeter in size. Once the eggs hatch, the adults will be about 1 millimeter. We are sending 10 eggs to the ISS and expect them to hatch within 1 to 2 days of receiving water and food.
We selected the FME Type 3 for our experiment. The 10 eggs will go in Volume 1. In Volume 2, we are putting spring water and moss, and in Volume 3, we are putting 10% neutral buffered formalin. We are putting water and moss in Volume 2 because the tardigrades can eat moss and live in water. We are putting the formalin in Volume 3 to stop the growth of the tardigrades. We will have the same setup on Earth so we can compare the hatching rate as well as the growth rate.
With the first interaction, the astronauts will unclamp A. The eggs will come in contact with the water and should start the hatching process. With the second interaction, the astronauts will unclamp B. This will release the fixative to stop their growth after 12 days. Tardigrades can stay without water for decades. Their hatching process can be completed within 2 days.
The importance of sending tardigrade eggs to microgravity is to give scientists more information and understanding about tardigrades and their eggs. This will add an important piece of information to tardigrade knowledge. Scientists can learn more about the development of other invertebrate animals and help understand how animals hatch from eggs in microgravity.
As stated, we are sending 10 eggs. They are all expected to develop. The eggs were collected by Dr. Perry and her students over the winter. The introduction of water and the availability of food should allow them to start to grow. From what we have learned from Dr. Perry, this could be the first time that tardigrade eggs have been sent to the ISS. Once our experiment returns, we will look at the analysis, which states how many eggs hatch, the length of the adults. We will compare the number of legs, which should be 8, and body segments. We will also assess overall appearance of the tardigrades.
We were very fortunate to find Dr. Perry. She is originally from England and received her undergraduate degree from Exeter University. She completed her PhD on echinoderms in Florida. Since then, she has become more generally interested in the biology of lesser-known marine invertebrates. At Unity College, Dr. Perry has been researching tardigrades with student participation. When we collected tardigrades from her instructions by collecting moss and looking at the water, we were not able to see the eggs. We soon found out that the light to look at the tardigrades needs to come from an angle. We asked Dr. Perry if she could supply the eggs. She agreed and sent us 40 eggs to work with. Dr. Perry is also interested in the results of our experiment. We plan to share our results with her.
We would like to thank Dr. Emma Perry from Unity College in Unity, Maine. And we would like to thank the Springfield Public Schools and the Board of Education for supporting and funding the SSEP in our schools. And we would like to thank the Center for the Advancement of Science and Space, a national partner. And finally, Mr. Greg Salmon, our SSEP Coordinator and District Supervisor of Science. Thank you for listening.
Hi, my name's Anita and I'm from Wisconsin. Why did you choose these eggs instead of other eggs?
We decided to choose these eggs because they haven't been sent to microgravity before, and this is the first time someone has done this with their eggs.
Okay, thank you.
Hi, I'm Jordan and I'm from Stamford, Connecticut. Why are tardigrades able to survive such extreme temperatures and cosmic radiation, and how can we use this information to better protect our astronauts up in space?
Because they're an important part of the food chain.
Okay. Thank you.
Hi, I'm Jenna from Wisconsin. I know that this is not in the scope of your experiment, but have you thought about or read about any implications for like cloning or anything like that, or, in vitro fertilization or anything like that? I mean, that's what it brings to mind listening to you talk. So.
We have not found anything about cloning, but that would definitely be something that we would look into for the future. So.
All right, thank you.
It's your turn.
Hi, I'm Ryan from Stamford, Connecticut. I was wondering why you guys decided to put moss in the tube, since you said the water bears can survive for decades without food.
Do you want me to answer? Okay, so the eggs will not be able to hatch without water being introduced to the environment. So the eggs will stay in a tun state until water is entered, and that's what's going to start the hatching process.
Okay, thank you.